So in the previous video, we started graphing the sine and cosine functions, and now what we're going to do is we're going to apply some sort of movement into the functions. So the first thing that we're going to look at is look at these formulas. They're not really formulas, but they're basically a couple of I don't know. This is gonna shift the graph. So you have A, B, C, and D. So if you look at these two equations, they're basically the same. Now, you have to be careful with these minuses and these pluses. They may change, and that will change the direction of the sine and the cosine curve. So um, here, this A is basically the amplitude of the wave. So if I were to look at the sine function, okay, so let's start. So if we look at the sine function, y equals sine of x, and I were to graph it, here's my x value, here's my y value. So remember, we're always going to use the quadrantal angles, pi, 3 pi over 2, 2 pi. So let's just graph one period. So one period, remember, is one cycle. Sine always starts at 0, and it follows this pattern, 0, 1, 0, -1, 0. So that's the pattern that it's always going to follow. Okay, so this is a sine curve, only one cycle. Remember that there's more of this later on, but we're only going to graph one cycle. Okay, so that's the sine function, and this is the cosine function. So remember that the cosine function, here you have 0, pi over 2, pi, 3 pi over 2, and then 2 pi, 1 and -1. Remember that cosine starts at 0. I'm sorry, starts at 1, then 0, then -1, 0, 1. So that's the pattern for the cosine function. Okay, and it kind of has a shape. Okay, so always remember the shapes. Okay, now in this case, this A, which is the amplitude, is basically how high the wave is from the midline. So if you think of the midline to be this guy where you kind of divide the wave in half, the amplitude is how high this guy is from the midline. As you can tell, this is only one unit up. And that makes sense because the number right in front of the sine and the cosine is just a 1. However, I can change that. If I were to change the A to a 2, then that means the sine and the cosine function is going to be now 2 units. Okay, so twice as long. So B here is related to the period. Okay, so basically, if you have a number in front of the x value, so if I had like sine of 2x, that's going to affect the period. It's not going to be from 0 to 2 pi anymore. Now it's going to be something different. Okay, so the period, the way that you can find the period is by taking 2 pi divided by b, because this b is basically how much you are compressing or stretching the x values. C corresponds with the phase shift, which basically means you're shifting the graph horizontally. Okay, so that's what the C basically does. And D is the vertical shift. Okay, so basically, if you remember from Math 96, when you graphed parabolas, if you have a positive D, that means you're going to shift up D units. And if you had a negative D, that means you're going to shift down D units. And we'll do a couple of examples of that, especially if you forgot. But the way that we're going to do it, we're going to start off with just the value of A. Okay, so let's start off by graphing when the amplitude is being changed. So for example, this guy. So how is putting an A going to affect it? Well, remember that this is going to affect the amplitude. Okay, so let's start off by graphing this. So let's do a couple of examples. So graph one period of the following and give the domain and the range. Okay, so we know what the sine function looks like. So let's start off with the sine graph, sine of x. So we know that sine, and the easiest way to do this is to start from 0, pi over 2, pi, 3 pi over 2, 2 pi. So always start with this, with the quadrantal angles. You have 1 and you have -1. Okay, so you start 0, 1, 0, -1, 0. So this is one period. Okay, now again, you can choose any period that you want. This is actually the easiest one to work with. Okay, now notice here, the only thing that's really changing is this 3. This 3 is going to make the amplitude much higher. So basically, instead of this being 1 and negative 1, it's going to be multiplied by a factor of 3. So this guy's going to be multiplied by a factor of 3. This guy is going to be multiplied by a factor of 3. So that means, and also the 0 is also going to be multiplied by a factor of 3. But that's not really going to do anything. So basically, if I were to have 3 sine of x, that is basically saying that I'm multiplying everything by a factor of 3. So instead of being 1, 2, 1, it's going to be 1, 2, 3, 1, negative 1, negative 2, negative 3. Okay, so did anything happen to the x values? No, nothing happened to the x values. The only thing that this 3 did is just stretched it. So this is still going to be pi over 2, pi, 3 pi over 2, 2 pi. So at 0, nothing's going to happen. So at this point, that stays the same. At pi over 2, instead of 1, it's being multiplied by 3. So now this is up 3. Okay. At pi, you're still at 0. At this guy, you're going to be at negative 3. And then this point is just going to be 0. Okay. So you can see here that the wave itself is now stretched out 3 units. Okay, so I basically just stretched the graph vertically. Okay. Now, what will be the domain? Now, the domain in this case, remember, the domain is all x values. Now, remember, we've only graphed one period, so we know that there's more values that exist. Well, the good thing about these guys, the domain of sine and cosine, is always going to be all real numbers. So always from negative infinity to positive infinity. Okay, so the domain here is going to be from negative infinity to positive infinity. Okay, now the range changes. Okay, the range is going to change. So the range, remember, is the lowest y value to the highest y value. So if you look at the entire graph, you can see that the lowest y value that this graph goes to is negative 3. So that's the lowest value. And then the highest value is going to be positive 3. Now, how do we show that this is, both of them are included? Because you can see that they're both included. The way that we do that is we write brackets. Okay? Brackets around the numbers. That means that the number is included. Okay? And you can see that at 3 pi over 2, you have negative 3. At pi over 2, you have positive 3. Okay? Now, the parentheses, whenever you have parentheses, that means not included. You are not including that number. Infinity is just an approximation. It's not an actual number. So you write parentheses around infinity always. Okay? All right. So now let's try out the second one. Okay, so what happens when it's negative 2? Okay, so let's start off by graphing the cosine function, y equals cosine of x. Okay, so let's start off by drawing the parent function of cosine. So we're going to start with 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And this is going to be between 1, negative 1 and 1. So remember, cosine starts with 1, 0, negative 1, 0, 1. So the graph kind of looks like this. All right, so that's what the graph looks like. Now, what is this 2 doing? So this 2 is doing basically the same thing that the other guy is doing. It is multiplying everything by 2. Now, what about this negative sign? This negative sign means flip. So you're flipping the entire graph across the x-axis. So across this x-axis, that means that if this number is going to go now downward, it's now going to be a negative. Okay, so what exactly is this graph going to look like? So what is y equals negative 2 cosine of x going to look like? Okay, so let's start off. So notice that nothing is happening with the x values. Okay, so nothing happens. So this is still 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so nothing has happened with the x values. the y values are being affected by this -2. So basically, if you look, so let me write it this way. So let me write 1, 2, and then -1, -2. So you can see that the first number is 1. What am I doing with this 1? Well, the first thing that I'm doing is I'm multiplying it by a factor of 2. So now this guy is going to be at 2. But then when I put a negative, that means that this guy's not going to be at -2. So now at this point where it was 0, at x equals 0, this guy's going to be at -2. Okay? What about at pi over 2? At pi over 2 right here, this guy is going to be multiplied by 2. Notice that when I multiply this by 2, it's still going to be 0. When I flip it, it's still going to be 0. So that guy stays the same. Okay. Now the next one is going to be this at pi. At pi, you have this -1. Okay. So when I multiply it by 2, you're going to get -2. And then when I flip it, it's going to go back up to 2. So this guy's going to be up at 2. Okay. Then the other one, as you can see, this 3 pi over 2, that's basically the same thing as this guy. So that one's still going to stay at 0. Okay. And then at 2 pi, let's make that this color. You see that this guy is at -2. I'm sorry, at 1. This guy's going to be the same thing as this one over here. So that guy is going to be back at -2. So what I've drawn here is basically the same thing, but this guy is now flipped. Okay, so I kind of drew it kind of weird. Okay, so it still looks like a curve, but it's now flipped. So you can see from the left-hand side, you have kind of like a smiley cosine, and now you kind of have a sad cosine. Okay, so that's basically what the graph does. So this 2 expanded everything, stretched it out 2 units, and then it flipped it to a negative. Okay, so if you look at the domain, remember, is always going to be from -infinity to +infinity, because you can plug in any x value in there. The range here, so what is the minimum y value? The minimum y value is going to be -2, and that one's included. And the maximum y value is going to be a +2. So it always goes from smallest to greatest. So this is going to be the domain and the range, and this guy is going to be my graph. Okay. Now let's do the last problem. So y equals -1/4 as sine of x. So let's start off by drawing the sine of x first. So that's basically what, let's write down what sine looks like. So pi over 2, pi, 3 pi over 2, and then 2 pi. And this is going to be between -1 and 1. So with sine of x, remember it starts at 0, 1, 0, -1, 0. Okay, so we know what the general sine curve looks like. Whoops. This one I'm going to go a little faster. Oh gosh, I can't. Oh, there we go. Okay, so that's basically what the curve looks like. Imagine that it's hitting the points. And now remember that this 1/4 is going to multiply everything by a 4. So basically what's going to happen is that this graph is going to shrink. Okay, not only am I multiplying it by a factor of 1/4, I'm also flipping it. So basically this hump right here is not going to be on the bottom, and this hump up down here is not going to be at the top. Okay, so you can kind of imagine that the shape is going to be opposites. Okay, so nothing happens in the x direction, at least not yet. And then you're going to have the y values. So before the y values was at 1 and -1, now it's going to shrink. So now it's going to be at 1/4 and -1/4, because that's basically the amplitude now. So it's going to be -1/4 sine of x. So this guy is going to stay the same when I multiply it by 1/4 or in a negative, so that stays the same. At pi over 2, notice that this guy is going to be multiplied by a fourth and then a negative, so it's going to be swapped downward. So it's going to be down here. At pi, it's going to be basically the same thing as the purple one. It's going to stay the same. And then at 3 pi over 2, you have this negative 1 multiplied by this negative 1/4. That gives me a positive 1/4. And then finally, you have that's 2 pi. And at 2 pi, you have the 0. It's going to be the same thing as the green one and the purple one. So what you end up getting is a graph that kind of looks like this. So it's a much shrunk version of the sine curve. So I kind of squished it. Remember that the domain in this case is going to always be negative infinity to positive infinity. Remember that this is going to continue on. And the range, in this case, the lowest y value this can be is negative 1/4. And the highest y value this can be is positive 1/4. So this would be the domain and the range.